According to the National Electrical Code, all outlets within 6 feet of a sink or water source must be GFCI protected to prevent electrical shock hazards. This includes outlets for appliances like dishwashers and garbage disposals. Garbage disposals and dishwashers involve water and electricity, creating a potential for electrical shock if not properly protected. If water leaks into the wiring or appliances, it can cause a ground fault, which can trip the GFCI breaker and prevent an electrical shock. Here are the steps to protect appliances with GFCI breakers. Firstly, purchase 2 GFCI breakers of the same amperage as the existing breakers. Secondly, turn off the power at the electrical panel. Thirdly, remove the existing breakers and replace them with the GFCI breakers. Fourthly, turn on the power and test the GFCI breakers by pressing the test button. They should trip and reset. Fifthly, plug the garbage disposal and dishwasher into the GFCI protected outlets. The GFCI breakers will provide protection to the appliances themselves as well as the outlets they are plugged into. If the GFCI breaker trips repeatedly, it could indicate a ground fault or wiring issue that needs to be addressed by a qualified electrician. It is recommended that all homes be inspected and updated to meet current electrical codes, including the installation of GFCI protection where required. A ground fault circuit interrupter, or GFCI, is a fast-acting circuit breaker designed to shut off electric power in the event of a ground fault within as little as 1/40 of a second. It works by comparing the amount of current going to and returning from equipment along the circuit conductors. When there is a difference of more than 5 milliamps, the GFCI interrupts the current. A GFCI is not an overcurrent device, such as a fuse or standard circuit breaker, and will not protect against overloads or short circuits. A GFCI is designed to protect people from electrocution. Overcurrent devices are primarily designed to protect equipment from fire. GFCI protection has been required in residences by the NEC since 1968, starting with circuits that serve swimming pools. The requirements have expanded over the years to include other areas where electrical hazards are more likely. Article 210.8 of the NEC specifies where GFCI protection is required in dwelling units. This includes bathrooms, garages, outdoors, crawl spaces, unfinished basements, kitchens, and laundry areas. More specifically regarding kitchens, GFCI protection is required for all receptacles serving countertop surfaces. This requirement aims to protect users of countertop appliances such as toasters, blenders, and coffee makers from electric shock. GFCI protection is also required for receptacles within 6 feet of the outside edge of a sink. This applies to receptacles serving dishwashers and garbage disposals, as well as other appliances near the sink. The purpose is to protect people from electric shock while using these appliances near water. When installing GFCI protection, it is important to follow the manufacturer's instructions and all applicable electrical codes. GFCI protection can be provided by a GFCI circuit breaker or a GFCI receptacle. A GFCI circuit breaker replaces a standard circuit breaker in the electrical panel and provides GFCI protection for the entire circuit. A GFCI receptacle is installed in place of a standard receptacle and provides GFCI protection only at that location. When replacing a standard receptacle with a GFCI receptacle, it is important to properly identify the line and load conductors. The line conductors are the incoming power supply, while the load conductors feed power to other receptacles or devices downstream. The GFCI receptacle will have terminals labeled line and load. The line conductors should be connected to the line terminals, and the load conductors should be connected to the load terminals. If the conductors are not properly connected, the GFCI receptacle will not function correctly. After installing a GFCI receptacle or circuit breaker, it is important to test it to ensure that it is working properly. This can be done by pressing the test button on the device. When the test button is pressed, the GFCI should trip and cut off power to the circuit. If the GFCI does not trip, it may be defective and should be replaced. It is also a good idea to periodically test GFCI devices to ensure that they are still functioning properly. GFCI protection is an important safety measure that can help to prevent electric shock. By understanding the requirements for GFCI protection and following proper installation procedures, you can help to keep your home and family safe. In addition to the specific requirements outlined in the NEC, there are also some general guidelines to follow when installing GFCI protection. Firstly, always turn off the power to the circuit before working on any electrical wiring. This will help to prevent electric shock. Secondly, use only approved electrical components and follow the manufacturer's instructions carefully. Thirdly, if you are not comfortable working with electrical wiring, hire a qualified electrician. Working with electricity can be dangerous, and it is important to take all necessary precautions. The NEC is updated every 3 years, so it is important to stay up to date on the latest requirements for GFCI protection. You can find the latest version of the NEC at your local library or bookstore, or online. By following the NEC and these general guidelines, you can help to ensure that your home is properly protected from electric shock. Remember, GFCI protection is an important safety measure that can save lives. GFCI devices are designed to protect people from electrical shock by monitoring the current flowing through a circuit. If the current flowing into the circuit differs from the current flowing out by a small amount, typically 5 mA, the GFCI device will quickly trip, cutting off power to the circuit. This can happen if someone comes into contact with a live wire and provides a path for current to flow to ground. The GFCI device detects this imbalance and quickly shuts off the power, preventing a potentially fatal shock. There are two main types of GFCI devices: GFCI receptacles and GFCI circuit breakers. GFCI receptacles are installed in place of standard electrical outlets and provide GFCI protection only at that location. GFCI circuit breakers are installed in the electrical panel and provide GFCI protection for the entire circuit. When choosing between a GFCI receptacle and a GFCI circuit breaker, there are several factors to consider. GFCI receptacles are typically less expensive than GFCI circuit breakers, but they only protect the devices plugged into that specific outlet. GFCI circuit breakers, on the other hand, protect all of the devices on the circuit, but they are more expensive and require more complicated installation. Another factor to consider is the location of the GFCI protection. If you only need GFCI protection in a specific location, such as near a sink or in a bathroom, a GFCI receptacle may be sufficient. However, if you need GFCI protection for an entire circuit, such as a kitchen countertop circuit, a GFCI circuit breaker is the better option. It's also important to note that GFCI protection is not a substitute for proper wiring and grounding. GFCI devices are designed to protect people from electrical shock, but they will not prevent fires caused by faulty wiring or overloaded circuits. It's important to have your home's electrical system inspected regularly by a qualified electrician to ensure that it is safe and up to code. When installing GFCI devices, it's important to follow the manufacturer's instructions carefully. GFCI receptacles typically have 3 terminals: a line terminal, a load terminal, and a ground terminal. The line terminal is connected to the incoming power supply, the load terminal is connected to the outgoing power supply, and the ground terminal is connected to the grounding wire. It's important to connect the wires to the correct terminals to ensure that the GFCI device functions properly. GFCI circuit breakers also have terminals for the line and load wires, as well as a terminal for the neutral wire. The neutral wire is a current-carrying conductor that returns current to the electrical panel. It's important to connect the neutral wire to the correct terminal on the GFCI circuit breaker to ensure that the device functions properly. After installing a GFCI device, it's important to test it to make sure that it is working properly. GFCI receptacles typically have a test button that can be pressed to simulate a ground fault. When the test button is pressed, the GFCI device should trip, cutting off power to the circuit. If the GFCI device does not trip, it may be defective and should be replaced. GFCI circuit breakers also have a test button that can be pressed to simulate a ground fault. When the test button is pressed, the GFCI circuit breaker should trip, cutting off power to the circuit. If the GFCI circuit breaker does not trip, it may be defective and should be replaced. It's also a good idea to periodically test GFCI devices to make sure that they are still working properly. GFCI devices can fail over time, so it's important to test them regularly to ensure that they are providing adequate protection. In addition to testing GFCI devices, it's also important to be aware of the signs of a ground fault. Some common signs of a ground fault include a tingling sensation when touching a metal appliance, a burning smell coming from an electrical outlet, or a circuit breaker that trips frequently. If you experience any of these signs, it's important to turn off the power to the circuit and call a qualified electrician. Ground faults can be dangerous and can cause electrical shock or fire. GFCI protection is an important safety measure that can help to prevent electrical shock. By understanding how GFCI devices work, how to install them, and how to test them, you can help to keep yourself and your family safe from electrical hazards. The National Electrical Code, or NEC, provides specific requirements for GFCI protection in various locations. These requirements are designed to protect people from electrical shock in areas where there is a higher risk of exposure to water or moisture. Article 210.8 of the NEC covers GFCI protection for dwelling units. This section specifies the locations where GFCI protection is required, including bathrooms, garages, outdoor locations, crawl spaces, unfinished basements, kitchens, and laundry areas. In bathrooms, GFCI protection is required for all receptacles. This includes receptacles that serve countertop appliances such as hairdryers and electric razors, as well as receptacles that serve lighting fixtures. The reason for this requirement is that bathrooms are often damp or wet, which increases the risk of electrical shock. In garages, GFCI protection is required for all 125-volt, 15 and 20 amp receptacles. This includes receptacles that serve power tools, lawn equipment, and other appliances. Garages are often used for working on cars and other projects, which can increase the risk of electrical shock. In outdoor locations, GFCI protection is required for all 125-volt, 15 and 20 amp receptacles that are readily accessible. This includes receptacles that serve outdoor lighting, power tools, and other appliances. Outdoor locations are exposed to the elements, which can increase the risk of electrical shock. In crawl spaces, GFCI protection is required for all 125-volt, 15 and 20 amp receptacles. Crawl spaces are often damp and confined, which can increase the risk of electrical shock. In unfinished basements, GFCI protection is required for all 125-volt, 15 and 20 amp receptacles. Unfinished basements are often damp and may have exposed pipes and wiring, which can increase the risk of electrical shock. In kitchens, GFCI protection is required for all receptacles that serve countertop surfaces. This includes receptacles that serve countertop appliances, such as toasters, blenders, and coffee makers. Kitchens are often wet and have a high concentration of electrical appliances, which can increase the risk of electrical shock. In laundry areas, GFCI protection is required for all 125-volt, 15 and 20 amp receptacles. Laundry areas are often damp and have a high concentration of electrical appliances, which can increase the risk of electrical shock. In addition to the specific requirements for dwelling units, the NEC also provides requirements for GFCI protection in other types of occupancies, such as commercial and industrial buildings. These requirements vary depending on the type of occupancy and the specific hazards that are present. It is important to consult the NEC to determine the specific requirements for GFCI protection in any given location. In addition to the NEC requirements, many local jurisdictions have their own requirements for GFCI protection. It is important to check with your local building department to determine the specific requirements in your area. GFCI protection is an important safety measure that can help to prevent electrical shock. By understanding the requirements for GFCI protection and following proper installation procedures, you can help to keep yourself and your family safe from electrical hazards.